So hi, now we are going to see some more couple of examples using BioPython package. Okay, and the first example, what has been mentioned over here using Jupyter Notebook is nothing but add two sequences. Okay, for that you have to just write a command that is from bio.alphabet import generic underscore DNA. Okay, so we are working right now with respect to DNA sequence and comma generic underscore protein. So then once you do that, you have to run the cell and then you have to write the next command that is from bio.sequence import sequence. Okay, so this you will find in the same link, okay, which I will be sharing again with you. And then here is nothing but the command which I have mentioned, that is from bio.sequence import sequence. So again, I'm going to run that, and then now we are assigning the sequence. Okay, so sequence one. So we are adding two sequence, right? So we are just writing that is a sequence one so that we can understand very easily equals to sequence, and in that we have added a DNA sequence. Okay, and then we are adding a next sequence is nothing but again a DNA sequence, but there we have mentioned a sequence 2, and this is most, that is you have to just write this, that is comma generic DNA comma generic DNA. Okay, and then one by one you have to run that, and then we have to write the command that is sequence 1 plus sequence 2. Okay, and once you do that, the data is get printed over here, and it is mentioned that sequence is get added of this and this, and it is a DNA alphabet sequence. Okay, so now what we're going to do is just a trial. We are going to just try, that is we are going to take this, okay, just to see that do we get some error. Okay, so it's a DNA sequence, right? And this we are going to copy and then we are going to paste, but here we are going to just mention some protein sequence to just try. Okay, so for that you can give any of the protein sequence from here. Okay, so what I will do, I will just type one protein sequence, okay, like K P T N. Okay, and then we'll just write over here is nothing but this protein. Okay, and then I'm going to paste this. We are going to run this. Okay, so now I'm going to run first this and then this. Then I'm going to write this command and I'm going to run. Okay, so now you will see that it's two sequences are there, so it's getting confused. So for that you have to just write the same sequences, okay, like a DNA sequence, once you are just adding with any of the sequence. Okay, it should be a DNA sequence or it should be a protein sequence, then only it will get added properly because it recognizes it belongs to the DNA sequence, right? So now we are going to see one more example over here is nothing but to change the case of the sequence. So what has been done over here, we are going to see now, it's nothing nothing but it is mentioned that from bio.alphabet import generic RNA. Okay, so for that we have just added one more sequence over here is nothing but RNA equals to sequence, and in that we have included not a capital letter but in the small letter. Okay, so how to change this capital letter sequences or the small letter sequences into the upper case, what has been mentioned over here. Okay, so like this, if you have a sequence in lowercase, you can just convert into the uppercase using this particular command. Okay, so if you have downloaded the FASTA sequence, which is shown in the small letter, so how to just convert whole sequence into the uppercase. Okay, so this is the example RNA sequence small 8 eg ct. Okay, and then it is mentioned as a generic RNA, and then you have to write the command that is RNA dot upper. Okay, and it's nothing but this particular sequence get called. Okay, so we are going to run this. Okay, yeah, so I have run this and it is mentioned that it is RNA alphabet sequence, definitely. And then the particular small letter case has been converted into the capital letter. Okay, so we saw the adding of two sequence. Okay, with the same, it should be a DNA. Okay, once at a time, it should have to with DNA sequence, okay? Or it should be protein, and then it should be added all the sequence with protein. Then we saw the case with respect to the sequences. And one more thing I'm going to show you is nothing but to check the Python membership and identify the operator. It's nothing but in my particular sequence, do the some letters are exist, okay? So that this will help you if you're just working with any small, means the particular partial region in the sequence. So if you want to just directly find that particular peptide region or the partial region is available, so in that particular case, you can use this command, okay? So it is here example is RNA sequence, and then the same sequence which is over here. Okay, so we are going to just find that a small r is available in my RNA or not. Okay, so that is again the same example, small r in RNA. So we are going to run first this. Okay, so it's true. Okay, so small a is available. So if you use a capital A in R, okay, or RNA sequence, it is showing as a false, okay, because the same exact keyword is not available in my particular sequence. This is how you can check in a huge sequence if you're working with any form of analysis with respect to sequences. Okay, so this is a third what we saw, and the fourth is nothing but to find a single letter or the sequences of letter inside the particular given sequence. So for that, how you will do that? So it is some advanced version of this, you can say. Okay, so we have a protein and a source sequence and equals to sequence which has been mentioned over here. Okay, so here is a particular sequence which has been mentioned, and then it is showing as a particular. We are going to run this first, and then you see that protein underscore sequence dot find capital G is available or not. Okay, so for that you have to just run this. Yeah, it is showing as a 1G is that. Okay, whereas if you just run this with respect to 2G, we are going to see. Okay, so we have means a continuous 8 GG is in the form of 8. Okay, so like this, you can just try with respect to using this particular examples which has been mentioned with respect to BioPython, and using the link which I'm going to share again in the description with respect to this video. Okay, so you can just stay tuned with respect to this particular Futuromics regarding further videos with respect to bioinformatics analysis and also using Python for data science and machine learning point of view. So stay tuned. Thank you.